Okay, let's unpack this. Usually when we talk about hacking, the mental image is it's pretty sticky.
It is.
We're programmed to picture the guy in the hoodie, right? In a basement, typing furiously, green text is cascading down the screen, and he's trying to smash through a firewall.
It's the classic smash and grab mentality. It makes for great cinema, but terrible security analysis.
Exactly. But I've got this white paper in front of me today that basically says, erase that image. It's done. We're looking at a report titled Digital Camouflage, How AI Native Hackers Become Invisible to Security.
By Idris Iclek.
Yeah, I've been waiting for this one.
It was published just this morning, January 20, 2026. And the premise here is, well, it's unsettling. It argues the attack isn't trying to break the door down anymore.
No, not at all.
It's mathematically designed to be invisible.
It creates a chilling image, doesn't it? But you're right. We aren't talking about brute force. We're talking about something far more sophisticated. Iclek argues we've hit a discontinuity in cybersecurity.
A discontinuity. And honestly, reading through this, that doesn't feel like hyperbole. We aren't just dealing with faster computers. We're seeing a fundamental change in the nature of the adversary.
Discontinuity is a big word. It sounds like we fell off a cliff.
In a way, we have. The report says we've moved from the digital corporation, where humans use digital tools, to an autonomous industry. The hacker isn't a person anymore.
The hacker is a system.
A system that evolves in real time.
That is exactly what I want to get into, the autonomous industry, because there's one statistic in the executive summary that genuinely made my jaw drop. I had to circle it 3 times. The 82-to-1 gap.
That is the headline figure. It's staggering.
It is, but I want to push on it a bit. 82-to-1. The report estimates that autonomous agents, AI-driven attack bots, now outnumber human defenders by that margin. Is that are we just inflating the numbers with dumb bots?
See, that's the scary part. We aren't. 2 years ago, maybe. But in 2026, when this report refers to an autonomous agent, it's not a script that just pings a server.
Yeah.
It's talking about agentic AI. These are systems capable of reasoning, planning, and executing complex tasks without human oversight. So imagine you're a security analyst. You're one person.
Okay.
Standing against you are 82 distinct, intelligent entities actively probing your perimeter.
So it's not a zombie horde of mindless bots. It's a coordinated team. That's not a fair fight.
It's not.
Imagine a security guard trying to watch the front door while 82 people are picking the lock at the exact same time.
And it's actually worse than that analogy. Because humans need to sleep. Humans get coffee breaks. Humans get alert fatigue.
Right, you just stop noticing the flashing red lights after a while.
You do. You miss things.
Don't you?
But the swarm, it doesn't sleep. It doesn't get tired. It operates on a scale of reconnaissance that is physically impossible for humans to match. They can test your defenses 24/7.
It turns security into a pure numbers game, and we are just losing on volume. But the report makes a distinction that I think is even more important. It's about the mindset, if you can call it that, the shift from deterministic to probabilistic logic. Can you break that down for us?
This is the key insight. In the old days, like 3 years ago, a hacker might write a script. If A happens, do B. If B fails, try C.
It's a flowchart.
Exactly, it's a flowchart.
Yeah.
That's deterministic. It's rigid. If you're a defender and you know the script, you can block it. It's like a train on a track.
You just derail it, put a barrier on the track.
Precisely. But these new AI native hackers use probabilistic logic. They are goal-seeking. They don't have a script. They have an objective.
Yeah.
Say, steal the customer database.
Okay.
They look at the environment, they try something, get feedback, and then they calculate the probability of the next best move.
In real time.
Yeah.
So it's not a train on a track. It's a GPS navigating through heavy traffic. If one road is blocked, it doesn't just stop. It reroutes instantly.
That's a perfect analogy. They're improvising based on the resistance they meet. It's like playing chess against a grandmaster who isn't just following an opening book, but is adapting to your specific weaknesses in the moment.
They're improvising. That is terrifying. And this leads to another concept the report talks about, which is my favorite term of the year so far, even if it's scary: vibe crime.
Vibe crime.
It sounds funny, like something from a cyberpunk novel, but the implications are deadly serious.
It's about the collapse of the skill barrier.
That's it. It used to be you had to be a technical wizard to pull off a major hack. You needed to know Linux, Python, networking protocols.
And now?
Now, specialized platforms let low-skill actors translate natural language intent into complex exploits. You don't need to know how to code a SQL injection attack.
You just ask for
You
it?
just go to one of these platforms, these dark GPTs, and say, In plain English, I want to access the back end of this HR portal and dump the salary data.
They state the intent, the vibe, and the AI handles the execution. It translates that vibe into the actual malicious code. It democratizes cybercrime to a terrifying degree.
So you don't need to know how to hack anymore, just what you want to steal.
Exactly. It lowers the barrier to entry to almost zero. But the core of this deep dive, the digital camouflage part, is how these attacks hide. This isn't just about getting in, it's about staying there unseen.
Yeah, let's get into the how, the technical stuff. The report talks about evasion attacks and adversarial perturbations. Now, to me, this sounded like optical illusions for computers. Is that a fair way to frame it?
It's close, but optical illusions work on human perception. These work on mathematical perception. An adversarial perturbation is when an attacker takes a file, say a piece of malware, and makes tiny, subtle modifications to it.
Modifications a human wouldn't notice.
Completely invisible to the human eye. If it's an image, they're changing pixel values by a fraction of a percent. But those changes are calculated to traverse the decision boundary of the AI security model.
Okay, decision boundary sounds technical. Let's unpack that.
Imagine a map. On one side of a line is safe, on the other is threat. The AI draws that line based on its training. The attacker uses their own AI to find the exact direction to push that file so it crosses the line.
So to me, it looks like a virus.
To you, it does. But to the antivirus AI, because of these invisible math tweaks, it suddenly looks like a harmless spreadsheet.
The report used the panda example, right?
Classic example, yeah.
Yeah.
You show an AI a picture of a panda. It says, panda, 99% confidence. You add this invisible layer of noise, this perturbation, and suddenly the AI says, gibbon, 99% confidence.
Whoa.
The image hasn't changed to our eyes, but the machine is effectively hallucinating a totally different reality.
It's forcing the computer to lie to itself. And this isn't just digital files. This bleeds into the physical world. This was the part that made me look out the window at the street signs.
The physical world camouflage is where this gets really dangerous for public safety. The report cites stickers placed on stop signs. To a human driver, it just looks like graffiti.
Messy, maybe some vandalism, but it's clearly a stop sign.
But to an autonomous vehicle, to the computer vision system, those specific stickers, placed in that specific pattern, might tell the car it's a speed limit 45 sign.
And the car doesn't stop. It accelerates through the intersection.
Right. And then there's the adversarial fashion, the eyeglass frames.
The frames with weird patterns on them.
Exactly. They're designed to confuse facial recognition. You walk past a surveillance camera, and instead of registering your face, the system just sees nothing. Or it registers you as someone else. It's an invisibility cloak, but only for algorithms.
So that's evasion. That's tricking the guard at the door. But there's something even more insidious mentioned, model poisoning. This sounded like the long game to me.
It is. Evasion happens at inference time when the model is running. Poisoning happens during training time when the model is learning. If you can inject bad data into the training set, you compromise the model's worldview forever.
It's like brainwashing the system before it's even deployed. The backdoor trigger concept was the one that stuck with me. How would that work in a corporate setting?
Sure. Let's say a company buys a security AI that updates itself on new traffic. An attacker slowly feeds it data that teaches it. When you see this specific weird string of text in a file header, that file is safe.
Like a secret handshake.
Exactly like a secret handshake. The model works perfectly 99.9% of the time. It looks trustworthy. But if it sees that specific trigger, that unique pattern, it executes a hidden instruction to let the attack through. It's a sleeper agent.
That is incredibly devious. And what about queen label poisoning? That sounds like a contradiction.
It's very sophisticated.
Yeah.
Usually to poison a model, you have to mislabel data, tell it a dog's a cat. But modern systems filter that out. Clean label means you use images that are correctly labeled, but you tweak the pixels just enough to shift the model's understanding.
You're just nudging the decision boundary.
Millimeter by millimeter until your attack falls into the safe zone. It's like gaslighting the AI over months.
While they're doing all this subtle stuff, they're also doing something called LLM jacking. I laughed at the term, but the economics of it are actually pretty painful for the victim.
It's adding insult to injury. LLM jacking is where attackers hijack your enterprise AI, the big expensive models you pay for, and use them to run their tasks.
So I'm the victim, and I'm paying for the electricity and the compute power you're using to hack me.
You are subsidizing your own destruction.
Yeah.
And once they're in, they might do model extraction. Imagine you have a proprietary AI that predicts stock market trends. That's your secret sauce.
Right.
The attacker queries your API thousands of times, mapping out your model's responses. They're reverse engineering the brain of the company.
They steal the whole thing.
Effectively, they take it offline, study it, find all its blind spots in private, and then come back with an attack that is guaranteed to work.
It's corporate espionage on steroids.
Hmm.
But here's what I keep coming back to. We have spent billions on cybersecurity, firewalls, antivirus, all of it. Why is all of that failing? Why are the old shields useless?
Well, the report points to three main reasons. First, our reliance on signatures. The old way was looking for a fingerprint of a virus. But AI-generated malware is polymorphic.
Polymorphic, meaning it changes shape.
It alters its own code continuously. The hash, the digital fingerprint, never matches a known signature because it's never the same twice. It rewrites itself every time it replicates.
So your antivirus is looking for a mugshot of a criminal who changes their face every 5 seconds?
Exactly. So signatures are dead.
Okay, what about looking for weird behavior? Static behavioral baselines. If a program starts deleting my files, shouldn't the system notice?
It should. But remember the reconnaissance capability. The attacker's AI is specifically trained to mimic the victim's legitimate workflow. If the accountant usually opens Excel at 9 a.m., the AI hacker does exactly that.
While siphoning off data in the background?
It blends in with the noise and rides the rails of your normal activity. And finally, there's model opacity, the black box problem.
Meaning we don't know why it works.
Or why it fails. Even if you catch an intrusion, forensic analysts often can't explain why the AI defense was bypassed. And if you can't understand why you failed, you can't patch the hole.
That feels like the biggest problem. We've built systems we don't fully understand, and this brings us to the real-world impact. We aren't just talking about stolen credit cards anymore. The healthcare scenario. That one really got to me.
That is the most disturbing example. We trust medical imaging implicitly. If the MRI says there's a tumor, there's a tumor.
Of course.
But a poisoned diagnostic AI could be manipulated to add or remove evidence of disease.
Just pause on that for a second. Add or remove tumors.
Think about the consequences. Systematic misdiagnosis. Patients undergoing chemotherapy for cancer they don't have. Or patients being told they're cancer-free when they actually have an aggressive tumor.
It's not just theft, it's sabotage. It destroys the fundamental trust between a doctor and a patient.
That's the goal. Chaos. And the same logic applies to the finance scenario, the CEO doppelgangers.
We've seen deepfakes before, but the report says this is next gen.
It's interactive. Not a pre-recorded video. It's a live video call where the AI is generating the voice and face in real time, responding to your questions. It passes liveness tests. You're looking your boss in the eye, hearing their specific vocal tics, and they're telling you to wire $50 million.
And it's not them.
It's an AI agent wearing their face.
And the third scenario was critical infrastructure, the smart grid.
Right. False data injection. Tricking control systems into thinking the grid is unstable when it's fine or stable when it's about to overload. The system reacts to the false data, potentially triggering cascading blackouts.
So healthcare, finance, power, nothing is off limits. And the people doing this, they aren't lone wolves. The report describes a new criminal ecosystem.
It's an economy. The supply chain is fragmented and automated. It's a gig economy for fraud. You have offensive prompt engineers experts who specialize solely in designing jailbreaks to bypass the safety alignment of legitimate LLMs.
So their whole job is figuring out how to make the nice AI do bad things.
Exactly. Then you have identity brokers, automated services that churn out deepfake personas, and data monetization analysts, AI agents that parse terabytes of stolen data in minutes to find the highest value targets.
It's efficient, which is a terrible word to use for crime, but that's what it is. Okay, I feel like I need a drink. This is bleak. But the report does have a section on defensive strategies. Is there hope?
There is hope, but it requires a huge paradigm shift. The view is we need to move from prevention to resilience. We have to assume they will get in. The wall will be breached.
So how do we fight back if the walls don't work?
AI on AI defense. We need to use adversarial training to make our models tougher. We essentially had to attack our own systems constantly to inoculate them.
Fight fire with fire.
Precisely. Think of it like an immune system, not a castle wall. It needs constant exposure to threats to learn. Then there's formal verification, using mathematical proofs to ensure a model behaves safely. It's hard to scale, but for high-stakes things, it might be necessary.
And for the CEO doppelganger problem?
Zero trust identity. We have to move beyond passwords. We need continuous behavioral identity verification. The system shouldn't just check your ID at the door. It should be constantly verifying it's you based on how you type, how you move the mouse.
So privacy takes a hit for the sake of security.
That is the trade-off. And looking even further ahead, the report mentions the quantum threat around 2030.
Oh, great. Just when I thought we were done, what's the quantum threat?
It's the convergence of AI and quantum computing. The fear is that quantum algorithms will break the digital signatures we use to verify that a model hasn't been tampered with.
So we wouldn't even be able to prove that the security patch we just downloaded is legitimate.
Right. If that happens, you could have forged model updates at a global scale. You download the fix, and it's actually a virus. That's the horizon event we need to prepare for now.
Okay, let's zoom out. We've covered a lot. The 82.1 gap, invisible mathematical attacks, fake tumors, deepfake CEOs. It feels like a totally new world.
We are. The autonomous industry is here. The factory floor of cybercrime is now a swarm of agentic AI models focused on high-volume throughput.
So what does this all mean for the listener? What's the so what?
The so what is that we can no longer trust our senses or our traditional tools. We can't trust seeing is believing because of deepfakes. We can't trust the system says it's clean because of these adversarial attacks.
Security is no longer just IT support.
Not at all. It is a distinct, high-stakes discipline. It's an arms race where the weapon is intelligence itself.
That is a heavy realization. We've always assumed that if the antivirus slate is green, we're safe. If the video looks like our boss, it's our boss. That trust is gone.
It requires a new level of critical thinking from everyone, not just the tech team.
I want to leave everyone with a final thought from this deep dive. We've talked about how these AI agents can mimic normal behavior perfectly. They can erase their footprints. They can hide in plain sight. So here is the question. If AI can perfectly mimic normal behavior and remove all evidence of its own intrusion, how confident are you really that the clean systems you're using right now haven't already been compromised by a silent observer?
That is the question that keeps security researchers up at night.
And now it's going to keep me up at night, too. Thanks for listening to this deep dive. Stay safe out there and maybe double check who you're talking to.
Indeed.
Yeah.
Be vigilant.